Hello guys, here we have question number 8 from Check Your Understanding of the chapter Electromagnetic Induction from Pathfinder. Let's start. A perfectly conducting rectangular frame of sides A and B can rotate without friction about a horizontal axis A1 A2 in a weak uniform magnetic field of induction B pointing vertically upward and uniform gravitational field of intensity G of the Earth. Mass of the frame is m and its inductance is L. Viscous drag force of air is not negligible. Consider the following experiments. Initially, the frame is hanging motionless with a plane vertical and then it is with its plane vertical and then it is slowly tilted to a horizontal orientation and released. In which orientation will the frame eventually stop? And for part B, initially a small gap is cut in the frame when the frame is hanging motionless with its plane vertical. Now the frame is slowly tilted to a horizontal orientation. The gap is closed by the same conducting material and then the frame is released. In which orientation will the frame eventually stop? So for part A, what we need to observe is that for any orientation of the coil with respect to the vertical, there will be some current in the coil, and the torque due to the weight of the coil and due to the magnetic field will always try to bring it to a vertical plane, and that torques due to the viscous forces are always velocity dependent, so it can only be in rest. So for part A, it's simply the vertical plane in which it will finally. Now for part B, what we can here is the diagram I've drawn, and here the equations we can get are, first of all, the inductance times the current should be equals to the flux through the coil initially, which was B times A times B when it was put in a horizontal position and then it was left. So from here the current I equals to BAB over L, where L is the inductance. So from here the M vector will be equals to I times the area vector, which is AB, in the direction as shown in the figure. And now balancing the torques in this position, what we get is mg times a by 2 times sine theta is equals to m vector cross b vector, which is equals to b square by L multiplied by b into cos theta. So from here what we get is tan theta is equals to 2BAB squared over MGL. Now, as it is said that the magnetic field is pretty weak, so that angle theta will be quite small, so this can be approximated to be as angle theta. So yeah, this is the final angle at which it stabilizes. So yeah, this is the answer for the part B. So yeah, that's the final answer. Thank you.